everybody. My name is Rolf Langsdorf. In Perl you might know me as LanX. And I want to talk today about extending syntax, function programming means macros. It's a model I'm thinking about meditating for many years now, and making little progress little by little, and I want to show you where I am now. First of all, well, this is a proof that I can't handle Emacs and LaTeX at the same time. And Orkut. So, talking about Perl's future, this is more or less a symbol of the development of Perl 6. It's a monumental answer of all our questions, but it takes a long time to, you can say the first level was in 2000, then in 2001, and then we'll see how many years we have to go. But in the meantime, we have to think about how to bridge the gap between Perl 5 and Perl 6. It takes longer and longer and longer. I don't want to criticize Perl 6 here, don't get me wrong, but it's just a necessity that we have to prove that Perl 5 has still a future. And I have the deep belief that languages are undergoing an evolution. That is, there's no intelligent design like Pythonistas may believe in the benevolent dictator. So we have plenty of ways to extend Perl, like source filter or XS modules and pluggable keywords, which is a new feature, changing core and universal namespace, overloading operators, double declare, and or other brand new features which come with new Perl versions, but are probably deprecated in 2 subversions later, like smart matches and so on. So, may I ask you, who's shying away to combine those features? Do you? Well, you may use one of them or 2, but altogether you have to take a choice which feature to take to be compatible, to go into production. So the problem we are facing is the complexity of Perl is limiting such a process because they are not always reliable. They are complex in installation. They break development tools. If you have new keywords that don't work in your IDEs, they may not work in the debugger. You can't debug anymore because the line numbers are not right again. You can't tidy them anymore, and so on. They're critical in edge cases. You're combining 2 new features and they don't work together because they're not orthogonal. They're too slow, or depending on smoking new Perl versions, and you have to work on a Red Hat system, and you can't work with smoking new versions. So it's a dogma, and it's well known, only Perl can pass Perl. And the approach I want to go is just use the fucking Perl parser to pass Perl. Keep it simple and stay compatible. That is, the title of my talk today, Extending Syntax, is actually a hoax, because I won't extend syntax in this sense. I will use the syntax which is already there and use syntactic sugar to make it more sexy. So the overview from this what will come is I will show you 2 techniques to fulfill this. First, combining chaining functions in a way that they use special prototypes and are combinable and look like compound statements or operators, and sweeten this with syntactic sugar. And the other approach is to use a macro extension system, which derives from catching BD parts in a way to even enhance the results we have with functional sugar, to gain maximum performance and to reliably analyze the syntax that we created, and to gain more flexibility. If you have any questions, I'm thinking about, we have 50 minutes, I'm thinking about doing this talk in 40 minutes. Please keep them, memorize them, and ask them later. So let's take an example, the cross product in Perl 6. Perl 6 introduces a new operator, a cross operator X, for the mathematical cross product. This is Perl 6 syntax. So this is like nested arrays. It's nested lists. And you see we are multiplying 1, 2 with AB, and we get 1A, 1B, 2A, 2B. So creating all pairwise combinations. If you want to do this, wrong computer. If you want to do this with Perl 5, we can choose a prototype simulation with functions. We could define a function X, which takes by prototype a block and a list, and which just produces the same output, but with the caveat that we have to write 2 X's. May I ask, does it look attractive for you? More or less? Yeah. Well, someone may not agree, but the code block only returns list of values, and so the X's are chainable. That is, we don't need to find a list because the list is optional. So we can use it compatibly in statements we already have. So it's orthogonal. We can use it. We can chain it with map and grab because it's returning lists. We can use it in a for loop and so on. So it's compatible to the syntax we already have, and we can think about even extending the possibilities we have in Perl 6 by using the $_ variable for special features. But that's a matter of debate. Let's try other operators. Now, Perl 6 introduces meta and hyper operators. Like, you want, you have a kind of a cross product. No, you have a zip, we are combining 2 lists, and you are multiplying the elements. That's the first example. The next example is you are using an implicit assignment. The third one, you are just negating every element. This could be simulated with the same syntax. You define a function z, which works similarly to x, and you can even have an extension here that you pass an anonymous sub, which is applied to every element. Okay, that was a simple example how to simulate operators which are projected for Perl 6 and Perl 5. Let's take another example. This is actually from the Euler project, and it's called Pythagorean triplets. Well, you all know the Pythagorean equation a plus a squared plus b squared is equal to c squared. And if you want to have all results where a plus b plus c equals 1000, you can write it with a mathematical notation which is called, in some computer languages, LISP comprehension. So this mathematical equation is known. You all have seen it in school or university, I suppose. And we could even ask, give me 10 possible solutions and not any more. So if one is solve this in Perl 5, this could be roughly done like this. We define 3 loops, or 2 loops in this case, and we are trying to get all triplets, and we say we want to have 10 results, so we break the loop and we push. Now, how does it look like in Haskell? In Haskell, it's much smoother. We say take 10 of more or less a similar syntax to the LISP comprehensions. So it is a LISP comprehension, the mathematical notation. And Langsdorf even has infinite ranges. You can see here where the C goes from 1 to infinite. and it does lazy calculation. That means you don't create the whole list, you can take only the 10 elements and the 11th element is not calculated, and if you want the 11th element, you ask for it. It's a stream, it's an iterator which brings all elements. Just checking how good I am in time. So am I too fast? Just tell me. So if we want to simulate this in Perl 5, we could chain functions again. And the fat comma is just syntactic sugar to show the differences between the functions. And we define a function take and a function from with these prototypes. And they take a block, a code block, and two scalars, which are partly optional. In the end, if we analyze what's happening in the above line, you have to look at the lower line, and you can see it's just nested functions. The last function is returning a result, the middle function, which is returning a result to take. And I realized this by passing iterators. And it's just, there is no calculation done in from. There's no calculation done in the second from, it's just done within the take. And each from is adding more semantics to what is supposed to happen. So, do you believe me that that's possible? Okay.
So from returns an iterator?
Yeah. So let's take other examples which can be covered with functional sugar. Perl 6 comes with signature and parameter evaluation, something which is missed in Perl 5 very dearly. And we have now an approach in 520 with signatures, and that's a typical example. If you're still bound to older Perl versions, you can't use it if you want to be compatible. Perl 5 has in core only one module since 5.9. It's parents check, and that's the syntax. Would you say that's attractive?
Well, you are not obliged to use core models. You can use any suitable span model for that.
Yeah.
Why not?
Because some people only want to use core modules, and if we're talking about a language extension, it should be some kind of core. Because otherwise people won't use it, people would use different modules. But could we discuss it in the last 10 minutes, please?
Sure.
So, there is a CPAN module called Smart Arcs, which is already much more attractive. You can see there is no add underscore past, because it uses a not very well known but well documented feature to access the parameters, the arguments of within the call chain. So args is just a function which is called within func2, and it accesses the arguments not from args and from the above call chain, and does the calculation and sets them. The arguments are within the function defined with my, and so they can be set. Which is already, would you say, that's already more attractive than before?
It's very similar to get on long in a sense. That you just sort of define what your arguments are, and the values just arrive magically into them.
But we still need hashes to pass options. But we could go even further. Why not adding more sugar? Oh, one more example that I can't handle Emacs and org-mode and LaTeX at the same time. We could say we pass the default arguments by assigning them to the variable. We could even, if we allow to use BD parse, set name parameters. Say we have variable key and value are taken from the hash, which is passed, and with the keys key and value. We could have arguments which are named differently, named parameters. We could have optional arguments if we allow to use attributes. We could use attributes to mark variables which are supposed to be optional. And we could even use constraints which are defined in Perl 6 to say a variable has to be integer, a variable has to be a float, or a variable has to be greater or bigger or something. That's pretty near to what we want. Well, okay, we have the problem that we have to repeat my every time. That's a flaw in the syntax. But implementing this is not the problem. The real problem is the design of this, because there are many models which are spinning around. And this comes to your question, why not using a CPAN module? Because you have different models how to define this, and you have to carefully design how you do it. So you can go after the Perl 6 module, you can go after the Perl 520 model, the new one. You can copy one of the modules which are already on CPAN. You can try to do it like Python does it. You can do it like Ruby does it. So designing is much more complicated. To have a design where you're sure that it will be suitable in the future than just implementing it. And the other problem, which leads us to the next part of this talk, is speed. Because you can do much optimization with this args function that I showed you, which is taking parameters and setting them. But it's still an extra function call. You have a function call, you're calling a function, and to evaluate and to pass variables, you need another function call to args. You can never optimize this away. You need a way to inline this code. And that's where we go to come to macros. Now, first question, are you aware how macros work in LISP? Yeah. They are kind of functions. I will show you. But to understand how they are implemented here, you have to understand what the op tree is. If we take the function if you just take the code, which is a function code, take 1 plus 2. This is internally translated to an op tree after compilation. And this op tree, this is one representation of the op tree, is then executed. So what's happening is you have here this unary operator enter sub, and enter sub does what is defined afterwards in the tree. The function is called take. It gets a constant, which is 3. You see 1 plus 2 was optimized to 3 because it sees it's constant numbers. And this is all executed. You see you have this enter sub operator asks what is the name of the subroutine, what are the arguments to the subroutine, and calls it. And if you use the module bdparse, which is core, it just walks through the op tree, gets the parameters back, and it calls a function internally. bdparse is implemented in Perl, in pure Perl, using the B backbone, and is taking the calling for every in the tree functions which are reporting strings back to the upper functions up the tree. So if you use bdparse, take 1 plus 2, you get the Perl code back, take 3. So with optimization. I just included the optimization to show you that bdparse is not 100% reliable, because it tries to guess how the code originally looked like, but it's pretty good, and you can re-evaluate the code. So one use case. If you use data dumper, every one of you has already used data dumper, and you have a hash you want to dump. You have to pass reference to this hash, and you get the output $1 is this hash. So the information which hash was dumped gets lost. Now we can define a function which takes a code reference, like this one, DMP, dump, which takes the code reference, the block, and uses BD pass to get the names back and to dump them with, just as a simple example, how to use LPW2014. And so you can show the variables together with the data structure. Data dumper has a very awkward syntax to pass the variable name with the structure. So, as I told you, BD pass is written in Perl. It walks the tree, and this function pp enter sub, which was marked in red here, represents the opcode to enter a subroutine, to call a subroutine. So these methods reports source snippets up the tree, and that's where I'm getting in. I'm monkey patching pp enter sub. I'm using BD parse, I'm requiring it, and then I'm changing pp enter sub with a wrapper, which is just taking the arguments which are passed into the macro and changes them and in a different way, inlining the code I want to have at this part, and this is then returned as a string which is then re-evaluated. So as use case, too fast? I'm pretty fast with my talk, so as a use case, in Perl 6 we have an idiom for lazy iterators which is called gather take. Gather take is a kind of a return, but next time you call gather, you will continue at the point which is marked as re-entry, which is a very convenient way to define iterators. And it's sad to say Python has this for years now. So this is only roughly possible with Perl 5, because it's not lazy. Because we're not returning at this point, we're just pushing to temporary array. If we want to simulate this in Perl 5, we can do it with a lot of code and with goto. I know goto is frowned upon, but if we say at the point of the exit, this part which I call take is replaced by this do block, which defines a re-entry point, enter 1. And we define the entry, we say we did the exit at the point enter 1. We have this variable in the closure. And next time we go into the subroutine, it goes at the dispatcher line, go to $entry if defined entry. So the first time it starts from the beginning, the next time it's restart the function, it goes at the point of the exit. Clear more or less? But that's not the way you want to advertise Perl. I mean, you're in a discussion with a Pythonista, it shows that you're a generator, and you say, oh, I can do it with Go. What we really want is a prettier Perl 5 notation. This one is not returning an array, but an iterator, but we could easily tie this iterator to an array again to have a lazy array now. But I have to say, I'm showing you a lot of ways to construct new syntax and new features, new semantics. I'm not advertising the semantics. I'm not trying to explain them and not trying to justify them. This would include a day's talk. That's, please, if you think that you don't need gather take, it's okay. It's just an example how to implement something. So I had this discussion often enough. Then people say, I don't need iterators and so on. Okay, if you don't need them, don't use them. So this is the syntax we would like to have in Perl 5. Actually what we need is to expand take to this do block we showed before. And to wrap this goto logic around, and all of this without source filters, because source filters are not reliable. Now, if we define a macro take, which just returns this do block, this part is just a string which is returned, and it uses the variables which are passed to build this string, source string. And then we define a function gather, which is just doing putting in the templates before and after the new body. And the new body is expanded from the block which is passed. This original Perl 5 thingy. And that's a block. Gather just takes the block, the code block, and this is expanded, and the take is expanded to a do block. And this works. After patching, PP enters up, expand block is just calling BD parse, and the code is deparsed in a new way, entering the new code. So we are my talk is scheduled till 20 past? Okay. So advantages of this approach is it's just a minimal patch to BD parse. BD parse is part of core since 98. So it's extremely backwards compatible. It's written in Perl. That is, we have access to a much broader pool of developers which can help developing and continuing it compared to XS modules. So we can at least prototype and implement extensions without lengthy PL5P discussions. We don't need any C or preprocessor wizardry. It's less complex than fiscal laws in the end. It's just, you can just try and forget if it doesn't work. I mean, implementing an XS module or even a new feature in Perl is a huge investment, and this is much lighter. Open issues are that BD parse is not always reliable, but we can catch these problems at compile time, or we can fix them. It's written in Perl. And re-eval has the problem that we might lose closure variables. Because what we're effectively doing is we're getting a source from someone we don't know, and using variables. We're putting source code around it, and we're expanding macros within it. And this code around and within may have new variables. And this is called a hygiene problem in the macro world to avoid namespace clashes. We don't want that those both variables are equally named. I just solved it, but I needed to use Padwalker for it to inspect which variables are used within this code which is included. It took me very long. I really tried to avoid Padwalker because it's not core. I've delayed this question to the future. Maybe I will find a way with maybe someone will come up with some B module wizardry that helps me to avoid Padwalker and to re-implement it in pure Perl. Then with this gather take example, there's a problem that you can't go into for each. So you have to catch at compile time if there's a for each in this gather take construction, and which is easily done. So it's a limitation. I'm not sure how to. For each has so many magic features that it's not really easy to circumvent them, to simulate them. And I've developed all of them in Perl 5.10, and now my new laptop has 5.14, and I see deprecation warning for gotos. But like gotos into complex statements. I've looked into Perl monks discussions, and nobody's really sure what this is supposed to mean and when it's issued. And there's so many deprecation warnings which never actually read deprecation. I have to check this. So, conclusion. I've done much research and meditation about the extension gadgets Perl has, and tried to identify the traps and the limitations and the breaks in orthogonality where you can't combine them. And I think this functional approach is a very good one, because at the end we were simulating with chained functions operators. We can simulate compound statements. We can simulate a lot of things, and with the syntactic sugar possibilities that Perl offers, it could look very good. And then with this macro possibility, we can even speed things up and make it more secure, because BT-bars can also be used to check if there is a for each loop, for example, which is forbidden. The minimal goal I have with all these techniques which I've assembled is to have a syntax toolkit to design internal domain-specific languages. I have to explain, domain-specific language is a term which comes from the LISP world, and nowadays we are distinguishing between external and internal domain-specific languages. Template toolkit is a typical example of external domain-specific language, because template toolkit has no programming language internally. This language is not Perl, so it's parsed and it's interpreted. An internal domain-specific language means you're using the language features of your own language to design a new language. Maybe you know Link from the C# world. You've heard about it, or VBNet. You can use it, I think, Visual Basic has it too, VBNet, and so on. It's a database language which is integrated within the language. With this approach, with combining functions which are passing iterates, so objects around.
Maybe you need to look at the LanX Perl.
Well, that's one of the problems if you're designing things. You can't have a look at everything, so you're giving talks and getting feedback. Let's talk about it later. And you could have domain-specific language for GUIs and for data formats, and it has to be said, sorry, typo. There should be standing that Ruby's sex appeal. You know, when Ruby came out, it was half as fast as Perl. And if you go into the internals of Ruby, into the semantics, it's more or less a Perl clone. It has so many things copied from Perl. The success of Ruby was mainly based on the attractivity of the language. And one thing which is overly hyped in the Ruby community are domain-specific languages, using Ruby to define new languages internally. So my maximum goal is to have an extension model for Perl, because you can start to have new features like gather-take in a functional way. No, gather-take goes back. The operators in a functional way. You can then use macros to have something like gather-take. And you have, talking again about evolution, you can check it out, you can prototype it, you can have a proof of concept in the functional part, you can do it with the macro part, and if it works out, if it's accepted by the community, because you never know what is accepted at the end, you can't guarantee that something is really accepted by the community. You can implement it in XS to have it even faster, more reliable, And at the end, if it works out, you can integrate it into core. So, and this all benefits of this approach is it's transparent for the masses. It doesn't only involve a core team in Perl 5P, which is P5P, which knows all the internals and all the traps and where the atomic bombs are hidden.
We don't talk about those. We
Pardon?
don't talk about those.
You don't know what?
We don't talk about those.
Yeah. You have fast prototyping. You can applicate it. You can use it very fast. You can test it in production without deprecation risk. It's backwards compatible. Functions. Come on. And you have a much faster, well, immediate. You have a much faster return of investment if you're trying to implement new things in Perl. And I have to say, I only used functions. Even the macros are only based on functions. I'm not trying to, like in LISP, it's possible to say operators are translated differently and so on. I'm not doing this, just functions. So what's the target of this future design strategy? First, I told you I have this design hell. What's the best way to combine all these features? You saw it with the signatures. And I think the best choice is to see it Perl 6, how Perl 6 designed it, because Perl 6 is based on the analysis of the Perl 5 weaknesses. And the whole design of Perl 6 has a reason. And it's because already 14 years ago there was an analysis phase where Perl 5's weaknesses were analyzed. So we don't need to reinvent the wheel, the design wheel. We could have a synergy between teams. So I've looked into the definition of Perl 6 and sometimes it's really a little bit fuzzy. And if we can implement it in Perl 5 and test it already, we can see if it really works out and how it is meant to be. And so we can have a synergy between the teams and better compatibility in both directions. The second defines feature design strategy is stealing cool stuff from other languages, but just in the next phase. If you look at 7 languages in 7 weeks, which is a very popular O'Reilly book, explaining 7 languages, Ruby one of them, and we could have a look at this and if there are cool stuff which we want to have. By the way, in Perl 6 definition are macros. Macros are supposed to work in Perl 6, so Perl 6 could do it too. If we have an implementation of cool stuff in Perl 5, we can port it later to Perl 6. So my dream is to create this missing link. Sorry, I'm not only amateur in Emacs and LaTeX, also in GIMP. This is supposed to be an ape space. And there should be the Perl 5 ape and the robot at the right. And you can see this is still a human. You still have the compatibility, you can still use the old modules, but you can have these robotic features by extending them. And, well, that's it. Questions, discussion, input.
So I've on and off considered building some sort of macroing system very similar to yours, in that you'd simply create a function with the macro attribute on it. But I pretty much come to the conclusion that there's no possible way to do it with strings, because you throw away way too much of the semantics, like list, character, and so on. So I kind of came to the decision that you have to do it by some kind of object wrapper around, not necessarily the op tree as a whole, but some simplified version of it. Do you have any thoughts on doing that? Because strings, there.
I'm not a C programmer, and I don't understand the op tree totally.
Yeah.
I'm very glad that there's BD paths, because I'm understanding more and more BD paths, little by little, and it's giving me the output. So if I want to understand an op code, without discussing for real with P5P.
Yeah. I mean, I think that...
And reading Perl guards, sorry, but yeah, but I know what
because you wouldn't want to wrap the op tree, because the op tree is way too geared towards how the interpreter will execute it,
Yeah.
you'd definitely want to still wrap something that was a syntax tree in that it would represent the program syntax, but as an object, so that individual variables weren't just their names, they really retained their identity, and you can do all the lexical hygiene and stuff and so on and so forth.
So what you're actually saying, let me reproduce it so maybe others will, maybe I will understand, others will understand, is instead of returning strings, you want to have an octree returned, which is integrating the other
Well, more an AST, yeah, but basically the same way that Lisp would do it, in that your arguments come in.
Yes, an abstract syntax tree, which is the closest to an abstract syntax tree is the octree.
Well, no, but it isn't though. The octree really does represent how it will run it, and Perl doesn't have an AST at the moment. So
yeah,
you need to
it's the closest.
But
it's the closest we have. Yeah, I agree with you.
Yeah.
This would be the much better and proper solution.
But it's
I gave this talk, well, parts of it, without this hygiene problems which are solved now.
Yeah.
I gave this talk, well, I've tried to discuss this macro system in 2011 in Riga. 2011, sorry. Sometimes when the German is coming through. I'm quite tired because I've spent half the night of designing the sheets, the slides. Sorry for my English, by the way. And I gave it in 2011, and you know, there were some P5P people running around Saffron, for example, saying, oh, it's not clean, I can do it easily, and that's one of the reasons I delayed it.
Yeah.
And I talked a lot with Rainy. I talked with... Yeah, he encouraged me a lot. And a lot of people have said, oh, well, you know this idea, what do you think about this idea? I was just presenting the idea. 100 people are coming to me, implemented!
Yeah. Oh yeah, but it's great to start. This is that I think long term the string is going to come back to bite you, and you do need a higher level object wrapper.
Of course, but I can have results now.
Oh, you need.
You know, that's the problem. I can also wait for Christmas. And then we don't need it anymore.
Yeah.
But I mean, Perl 6 is coming. Why do we need Perl 5 anymore?
I would like to add to that basically doing it with string, while the actual approach is very different from the source filters, but in the end, if you have to parse the source code anyways, then it's no different from the source filters.
No,
it's
it
exactly
is.
the same.
It is. No, it is. It is. That's a very good point. Because I'm not parsing the code like the source filter does. I'm using BD parse. It's already compiled. I'm parsing the abstract syntax tree.
Right.
And BD parse is
Right, but you are using BD parse in order to get a snippet of the code, which you then process as basically a procode string.
But largely all you're going to do is return it to have it eval again. So it would be equivalent to a source filter if you were going to start applying regex plus substras or whatever to those
that's a
things that
source. That's a source filter.
then that would end up. But if you just take them in as an opaque string and throw it straight out to eval again, it's generally nicer.
Yeah.
Do you know smart comments from...
In order to do that, you have to patch up the opcode tree. So you have to use bgenerate basically.
No, because you're returning the string again.
No, I don't use bgenerate.
Yeah.
This is what he was suggesting more or less.
Well, not bgenerate, but build a new thing.
Yeah, but that's... Yeah, do it.
It's not like this.
Yeah, do it.
I'm going to implement Python's yield first, though, and then I will get back to macros.
You're doing it for Python, though. I didn't know.
No. Implement the yield from Python in Perl.
I did. Well, it's on GitHub. It's my macro module is there on GitHub, and one of the examples is this get-take thing.
Well, as a coroutine thing. Yeah, no, I was going to do it as an async future wrapper.
Oh, yeah, there is a get-take based on how's the code from Mark Lehmann, this module.
Android email.
Mark Lehmann's module is async. No, what is it?
Coro.
Yeah. Coro.
Yeah, Coro does many evil things to the internals. I'm kind of doing a nice version of it.
Do it!
Christmas. Christmas is coming.
I tell you, this for each thing will bite you also. Will also bite you for each. But look.
Yeah.
Even this approach, even if you think it's not clean enough, it's good enough for prototyping. No, it's already good enough for prototyping, because what I told you, it's not the implementation which is the problem, it's the design, in my opinion. the design decision, once you've decided on the design, it will haunt you. It will, and people will use it and you can't get away. You can only release a new module and you have to explain and so on. That's why I'm very conservative in releasing things. But I'm now in therapy to publish regularly and often. People are kicking me regularly, so I'm releasing more and more. The code I've shown you, it's not all of them is released, but I will do it in the next 2 weeks, little by little, and discuss it on Perl if you're interested. But yeah, I agree with you, because what LISP is doing is during the parse phase, it's expanding the macros. What we are doing here, the difference is, it's not during the parsing phase that the macro is expanded, it's after it is already compiled, the macros are expanded and it's re-evaluated. Okay, questions more? I mean, we more or less agree, but do it.
You said you're wrapping PB into self. What do you mean by that? It's all pure Perl. How do you even get to
monkey patching? You can the symbol table hash of BD parse is in Perl. After you used BD parse, you can go into the namespace of BD parse and you find the function pp enter sub. You get the reference of this pp enter sub.
We all understood.
Real pp enter sub.
We all understood that we were modifying the pp enter sub C functions in the internals of Perl.
No.
Just the D parsing of it.
That's the point about BD parse. It's purely Perl and it's great. If you have no idea how the opcode works, look into pp enter sub.
We have slightly more, although probably totally wrong, understanding that there is a pp enter sub in the C code for Perl, and that's what I thought you meant.
I think BD parse is just mimicking.
There's a function with the same name inside Perl. We understood the wrong one.
I'm not a C programmer.
We got the wrong one. It's our fault.
Look, I'm a Perl programmer, and I want to extend Perl in Perl.
Yes.
So I have no idea about. One day I will try for proof of concept do something with the XS. But at the moment I don't even. I just went from assembler to Perl.
Okay, so that brings me. The other question I had was probably the same thing then. So you said that there was a small patch to BD Perl. I guess you mean it's monkey patching rather than actually.
I hope you're localizing your monkey patching so don't create other users.
Look into the code. It's in GitHub. You can look at it. It's one of the design problems. How should I call this module? Macro is a first level name, so macro repass. I don't know. I want to discuss it on Perl months to have some idea. I don't know how to call it. So I don't think that I will get the allowance to call it simply macro. But in GitHub it's called macro, and then if you go into macro, you have the example branch, and there's a gather take.
Call it macro something, because then we can carve out the namespace of other.
Yeah, because there's other macro module coming from you.
Yeah, exactly. Soon. Don't let me forget that.
But not Christmas.
No, why didn't it
Easter.
Easter, yeah.
Time for one more.
One moment. More questions? Good timing.